Good morning everyone. I am Prasanna Kumar from CSM Section C and today I will be presenting on minimum number of refueling stops. This problem deals with planning an efficient journey for a vehicle. We need to decide where to stop for fuel so that vehicle reaches its destination using a few refueling stops as possible. This concept is important in route optimization, navigation systems, delivery logistics and even dynamic planning problems in computer science. Problem statement overview. Given a starting fuel amount, a target distance, and a few fuel stations along with the route, find the minimum stops required. Each station provides a certain amount of fuel, enabling the vehicle to reach further. The goal is to reach the destination with the fewest refueling stops possible. The statement is simple. We are given a starting fuel a target amount, a target distance, a list of fuel stations, each with their location and fuel amount. Our goal is to find the minimum number of refueling stops required to reach the destination. If reaching the target is impossible, the algorithm should return -1. Key concepts and terminology. Fuel capacity, station location, and fuel amounts are essential parameters in this problem. The problem can be modeled as a greedy or dynamic programming problem. Understanding the problem constraints helps in designing an efficient solution. Before solving the problem, we need to understand some key terms. Fuel capacity, how much fuel the vehicle currently has. The station location, distance of each station from the starting point. Station fuel amount, how much fuel is available at the station. This problem can be approached using greedy algorithms or dynamic programming, but the greedy method is more efficient. Understanding these parameters helps us design an optimal and correct solution. Object-oriented approach overview. Using object-oriented programming helps organize related data and behaviors. Defining class like vehicle and station simplifies managing state and interactions. Object-oriented programming promotes code reusability and clarity in solving complex problems. Using object-oriented programming makes this problem easier to organize. We can model real-world competence using classes. We can create a vehicle class to manage the journey. A station class is to represent each refueling station. Object-oriented programming provides clarity, reusability, and easy management of states like fuel level and distance traveled. Designing the station class. The station class encapsulates the location and fuel amount of each station. It includes attributes like positioning and fueling along with relevant methods. Creating multiple station objects allows flexible management of station data. The station class contains two important attributes: position, distance from the start; fuel, which is amount of fuel available at the station. Each station obtains neatly encapsulate Each station object neatly encapsulates the station data. Using multiple station objects helps us easily pass, store, and process fuel station information. Designing the vehicle class. The vehicle class manages current fuel, position, and refueling operations. It tracks the vehicle's progress and decisions on when to refuel. Methods include moving, refueling, and checking if this destination is reachable. The vehicle class holds current fuel, current positioning, methods to refuel and move. This class models the behavior of the car in the real world scenario. Encapsulating these behaviors inside a class makes the logic clean and modular. Core algorithm overview. The algorithm calculates the minimum refueling stops using a greedy approach. It involves in interacting through station data and making optimal refuel decisions. The approach ensures minimal stops by always choosing the most beneficial station. Algorithm used to solve this problem is a greedy strategy. The idea is as we move along the route, we keep the track of all fuel stations we have passed. Whenever we cannot move further, we choose the station that gives us maximum fuel among the ones we have passed. This ensures that we refuel at the most beneficial station, leads to the minimum number of stops. Using a priority queue for optimization. A max heap priority queue helps select the largest fuel station visited so far. It allows quick access to the best refueling options at each step. This data structure is crucial for implementing an efficient greedy solution. To efficiently select the best station so far, we use a max heap priority queue. This data structure always allows us to quickly fetch the station with the largest fuel, maintain a set of all the stations we have passed but not yet used. This is crucial for implementing the greedy approach efficiently. Implementation Initial setup. Do initialize the vehicle's current fuel and position. Load all station data into station objects. Prepare the priority queue for managing potential refueling stations. During initialization, set the vehicle's starting fuel. Create station objects for all stations. Prepare a max heap for storing fuel values. Begin traversing stations in increasing order of distance. This setup ensures the algorithms proceeds smoothly. Algorithm step by step. The algorithm works as follows. For each station, calculate how much fuel is needed to reach it. If the vehicle doesn't have enough fuel, refuel from the priority queue. Count each refuel operation as a stop. Add the current station's fuel to the priority queue. After processing all stations, check again if we can reach the destination. If at any stage we cannot move further and the queue is empty, we return -1. Handling edge cases. There are some common edge cases. No stations available, but fuel is inefficient. Stations are too far apart. Target is closer than the first station. Station positions are unordered. Fuel is not enough even after refilling from all stations. The algorithm must carefully check these conditions and return the correct answer. Java implementation class design. In Java, we create three main elements: a station class to store position and fuel, a vehicle class to store current fuel and position, a main algorithm class to compute minimum refueling stops. Encapsulation keeps code clean and easy to modify. Java implementation main algorithm method. The method min refuel stops accepts target distance start fuel a list of stations include inside the method. A max heap is used to dynamically pick the best station. The function returns the minimum number of stops or -1 if it's impossible to reach the target. Code snippet station class. Here is how the station class looks. Here we have taken two two objects. We have defined two objects in int position and int fuel. Now in position and in fuel, this this dot position is equal to a new position. This fuel is equal to fuel. This structure keeps its station data organized in easy to use. Code snippet vehicle class. The vehicle class. Here we have defined a vehicle class. Here we have taken again two objects int fuel and int position. Public vehicle. This dot fuel is equal to start fuel. This dot position equals to 0. Public void refuel int fuel amount. Here we take this dot fuel plus or is equals to fuel amount. This class manages the vehicle's movement and fuel updates. The vehicle class manages current fuel and position, provides method to refuel and update vehicle state, encapsulates vehicle behavior within an object oriented design. Code snippet algorithm method. Here is the main logic. Here we have taken this method. Here we have defined int target, int start fuel, int stations. Priority queue. Here int max heap is equals to new priority queue. We have taken a new object. Int refuels is equals to 0, previous is equals to 0, fuel is equals to start fuel. We have defined new objects. Here we have used for loop, while loop, if statement, while loop, and we have written this return -1 if the car cannot reach further. This method implements the greedy approach effectively. Test the implementation. Testing the implementation. Testing ensures the algorithm works for all scenarios. We should test cases with no stations, cases with many stations, cases where fuel is inefficient, insufficient, large target distances. Using test data helps verify whether the algorithm returns correct results and handles edge cases properly. Advantages of OOPS in this problem. OOPS Object-oriented programming provides several advantages. Encapsulation keeps station and vehicle data safe and organized. Reusability classes can be reused or extended. Clarity the logic is separated into meaningful components. Scalability easy to add new features like fuel efficiency or cost. This shows how object-oriented programming makes the solution more robust and structured. To summarize, the minimum refueling stops problem can be solved efficiently using a greedy algorithm. A priority queue helps select optimal refueling stations. Object-oriented programming improves structure, readability, and maintenance. This problem teaches important concepts in algorithm design, optimization, and object-oriented programming principles. Thank you all for listening. Thank you.